Well, okay, my friends, I just got this from a friend of mine, and this is on Joe Rogan, and this guy is saying this is about quantum entanglement. Now, I have the sound turned off. I'm just going to play, and we'll be able to read what it says. It says, you've probably heard of quantum entanglement. It's the spooky particles become so connected that whatever happens to one happens to the other. They say even if they're across the universe. So they're tightly held together. Yes, that is 100% certain. But once they go apart, they don't come back together. Not the same ones. Watch. Here's what they're saying. The particles become so connected that whatever happens to one happens to the other. Instantly affects the other, no matter how far apart. Listen to this. Even if they're light years apart. Now you might be wondering, yes I am wondering, how on earth does that relate to our brains? Well, they're talking about quantum entanglement. They don't understand the nature of quantum entanglement. It doesn't mean that you started with a piece here and it split and came back no matter where. They're thinking it went out to do something and came back to that same particle. That is not the case. All right, this is Joe Rogan, and he's talking about quantum. They just recently made images of quantum particles entangled, and then they start to talk about how they will never separate. They always come back to each other, no matter how far away they are. They are entangled, and they love each other, and they will never break up. They'll separate and go their own ways, but they will always come together. It doesn't matter if they're on the other side of the universe. That's just not true. Okay, my friends, this is going to be a bit of a journey through some of these shots about light and about even biology, enzymes, bacteria, radiation sickness. It's all tied together. You say, how could that possibly be? Well, stay tuned. All right, my friends, this is what Joe Rogan is showing as a quantum entangled photon. Now, first of all, I will show you what a photon does look like. Secondly, I don't even think this is a real picture. I'm going to show you something that is the actual experiment showing photons. This is what quantum entanglement is right there. There's two quantum particles back to back. They are known as gluons, the black and the white. Two of them together, just like a bar magnet, make what we call a photon. One of them, just the black and the white, a single one, would be called a dipole electron. That creates heat. The two of them together create light, and the reason it's light, because it's totally surrounded by a magnetic field, basically. And I'm going to show you this with magnets. Very simple. And they oppose each other, and when these white particles bang into something, they start to glow. And I can show you that quite well. These particles here are the same as these particles here. However, they don't have enough energy yet to become fully photons. That's called neutrino. That's called a neutrino. This is a different flavor. It's a sideways flavor and this type of flavor. And then directly in line with the Venturi, which is the accelerator, these are concussing, so they turn into photons because in their mind, they just banged into something fairly solid because it's pushing backwards. I will show you that reverse. Bang, right here. This is coming this way, this is going that way. Bam! And then they just explode. And you get all this white arrangement going on there. So what were we just looking at right there? Those particles. And I say they were getting stronger and stronger until they turned into photons. Here it is right here. This is the laser light coming through here. It's a red pulsed laser. Now, it's headed directly for a Venturi. What's a Venturi? A Venturi is nothing more than a very tightly tuned funnel. So as that ball of magnetism comes, it's got to get crushed into that tunnel. half of that ball of magnetism is the dark matter, and it's got mass, and it starts to slap that white matter, which has no mass, and it can crunch down. But when it does, it gains energy like unbelievable, and that is energy unbelievably gained. However, the black and the white separate here. They do not come back together, the same black and the same white. There is absolutely no way that's happening. And I'll show you that in very, very close detail. Don't forget, this is the pulse laser. Doom, doom, doom. It has a tiny, tiny, tiny particle right in the middle of this. All right, but that tiny particle has a good field around it, which you can't see. It's like, and I can't find any material substance to it. But when you take two magnets and push them close to each other, they bump. What are they bumping into? Nothing. There's nothing there, but they're bumping, and we're going to go over that. So what does it do? It pushes everybody else, because everybody else has a field surrounding it. When this is going real fast as it is, get out of the way, and it just does just like the breaking the sound barrier with a jet. It takes right off and pulls itself right out of its own wave. You see that? Take your time and look and think of what you're seeing. All of a sudden, the particle shows up. And here it is, gaining energy, gaining, and all of a sudden it turns white. Why would that happen? Why do you think that would happen? Here you can see there's a particle there, but it's still red. This is a red laser, and it's still, pretty red, but it's getting glowier and glowier. And all of a sudden, bang, right there, turns white. What has happened there? It is concussing with the reverse wave because of this explosion. And when I say explosion, that is about that's literally, and I'm not kidding you, hold on to yourself, that is literally a subatomic nuclear explosion. Oh, come on, Roger. Yes. That's below atomic, so we don't have gigantic chunks of thing flying. We started with these little particles, all right, and which is the light, and it's only the two whites and two blacks. That's it. When they hit their particles, they got chunks that are just absolutely like pickup trucks. And when they go flying, they tear everything to shreds and knock down houses and blow people's heads off and all kind of stuff. What we have is just light. That's just light. That's the particle that they want to get down to. And we already got down to it. Now, so what does that mean? Well, what did that do? It exposed these fields. They were in the air. They're coming because the light just keeps flowing this way. And all of a sudden you see them. You never would have seen them before. This is, a pretty good shot of light coming through a red laser. You wouldn't even see that if it wasn't accelerating. I don't know what exactly you would see. You'd probably just see this little fuzzy looking stuff. But once it's accelerating, you can easily see that is a wave and the particles inside of it. And like I say, you take two magnets, and if they oppose each other, bump, 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 bump. If they attract each other, snap. What's the difference? Why would it bump one way and snap the other way? You say, well, it's positive and negative. Well, what does that mean? Well, I can show you what it means, because we can see it right here. Don't forget, that's the particle accelerating. Well, what does it look like when it accelerates? Don't forget, there it is. And at this point, it's really not a particle to speak of. Here it turns into a photon because of the pushback. Remember, all of the ones around here turned into photons because they were getting banged back at. You see them? A photon makes a field. But it has to hit something really strongly to make that field glow. It's pulling forward pretty damn fast, you can see, so it's glowing. But what you can see, this is pushed back at so incredibly hard, it's just sizzled. Same thing here. That is energy on steroid energy, and that is a subatomic nuclear explosion. The black separated from the white. And I showed you the black and the white. There they are right there. When it hit that Venturi, boom, all bets are off. The white is all by itself, the black is all by itself. Now here's up close. Don't forget, there's the particles. That is the photon. This is before, this is the colorized version, and this is just black and white. Now, what do we see? This one is white. That is called downspin. They always spin this way, no matter if they're going up on sideways or wherever. They always spin according to the polarity of the Earth. And I don't care where you are on Earth, you always go towards the center of the Earth. It will spin according to the polarity of the Earth. So just think of it that way. Now, you can see the glowy edge around it, and that's what they say. And they say, this is from Fermilab. Well, this is our work here, but here's what Fermilab did, the same stuff. And they show that these particles here can get big and get small, and they don't seem to have any mass to them. And that's what creates the field. That's what creates a big field, where you push two magnets together and bump, 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 bump. That's what's bumping against those little particles right there. You see those little particles? They are pushing back against this invader. He says, get out of my way, get out of my way. And they say, oh, yeah, you get out of my way. And I call it push to shove. And this one's a strong guy, and he pushes everybody out of the way. However, at the same time, he gets bigger and bigger and bigger, and all of a sudden it flips. And then it goes to a downspin. Upspin. This is a downspin. The particles at the bottom has all the energy when they take the shot of it. If they take another shot of it, and the white one's here, the other white one's going to be back here, and I can show you that right now too. Because this one here is gaining energy as it's moving forward. Here, it's still a neutrino. I hope I grab all the rest of this stuff. Here, it's still a neutrino. Here, it turns into the photons. And here, it explodes into the bits and pieces. Anyway, I'm not sure you saw what I was showing before, but this is directly from CERN and Fermilab. This is actually from Fermilab's article, saying this was the fixed particle, which is that, has a glowy edge around it, which is this. And this one, they say he can't find any mass, which I agree, is this one. And it can get bigger and smaller. I agree, depending upon how much concussion. Now for him, he said the more you look at it, the more the field grows. Well, that's because he's looking at it. It's because he was putting energy into it to look at it, like highlighting it harder and harder, and that makes it push back harder and harder. That's all it is. That's called the observer effect. And I was in that article. It says the closer you look at it, the stronger the field becomes. Well, it has nothing to do with that. Looking at it, it's the more energy you pump into it, the stronger it gets. We're accelerating it, so we're making it get crazy. Now, here's why I say they are never going to be the same particle coming back together. Here's the Venturi. Remember, those particles were together. There was a little box of particles right here. At the Venturi, the whites can squirt through the little Venturi. The black can't get through because they can't get smaller than this. The white can get smaller or bigger. And at the Venturi, it gets squirty. That's what I call squirty. It separates. And the black just keeps slapping and slapping and slapping. And the white just starts squirting through this little tiny slit. There's a very small slit. And it's angled in. And those particles come together at the slit, and then they explode. They're just completely apart. I think we can use this right here for electricity. That's, in my mind, that is 100% electricity. There's no black whatsoever. The white is the particle that has no mass and all the energy. They think that's what a photon is. A photon contains dark matter too. it contains that black. Now think about this. Do you think that that black that's separated here jumped over the top and because they come right back together instantly. They don't stay apart. You can't keep those two particles apart for more than an instant. They will find somebody else. They'll find somebody else right away. You know, if you can't be with the one you love, find the one you're with. You know, they don't come back together. It's not like they're entangled for life. See, this is from CERN. This is what they consider their particle zoo. They take huge particles, they call them protons and neutrons. They're huge. And they slam them together and they get all this debris coming around. Now, what do they see? The smallest particles that they can possibly find from that debris, over and over and over and over and over. They keep looking to see for years and years and years. And here's what they have found. They say these little green, blue, and red balls by themselves, they see these right here. This is the one we're going to focus on because that's a photon. They see them kind of big and strong, and then they see them kind of little and weak, and somewhere in the middle, and then they see other particles that are just bits and pieces of things. Now, I say what they had done was slam two big balls like this together, and they got all that debris flying. Now, an X means it could be a chunk this big. These ones here are the smallest bits and pieces, and then they have the X ones, could be any size. Could be this big. All right, so we worked with the light. Light is this one right there. That's what light is. And I can show you that because I can prove precisely what I'm saying. Don't forget, they see these. They see them in little bitty ones. They see them a little bit puffier. Then they see all these, the red, green, and the blue colors. Now, why do they see that? Well, that's because that's what light's going on, is with these colors, first of all. Secondly, what they are seeing is this. That's the photon. Remember, they had a blue and red, but it's not. It's the black particles are always the black, and then the white ones could be any color, basically, I think. But I believe they're red, blue, and green is the three separate layers of particles that are standard in protons and neutrons. They have layers of tiny particles that surround the black center. And that's dipole electron flood theory. As a matter of fact, let me just show you that. This is what it is right here. And this is my theory, dipole electron flood theory. Oscar Rosales did this for me, made a fabulous presentation based on my specs. The center is all the dark matter. That's where all the dark matter is. We've never even known it was there. That's the only thing that has weight and substance. That's why everything is made out of dark matter, surrounded by the white particles, which are the tightest ones are blue. The next ones out aren't quite so tight, they're green, and the ones out further out are red. And they surround the core. And that's what creates these different colors, first of all. Secondly, anytime you bounce into one of these, they bounce back. It's like a balloon. So we never saw the dark matter that's inside. The only reason we saw it was because when we splattered the thing, it sits on top of the white matter. You see? That's the only reason we can see it. It's everywhere. It's everywhere. But the only reason we can see it is because it's splattered and sitting on top of the white, obscuring the white from hitting us. But there's black all over here. There's black in here, black in here. The only way you can see it is where it's just nibbling in. And then it fuses right about here. They really just jump right in. And that's where you get all the Higgs fields. You want to see Higgs fields? This is when it squirts out the other side of the Venturi. You get one serious blast. And here is that serious blast. That's coming out of Venturi. And it's starting to catch on to some black ones. You see it? There's a few here and there. But then it just splatters in and just like it crashed into a wall. And then they start to squirt out and create these fields. You see that field is being created right now. It's hitting right there and spinning that into a field. And they all create these fields. Those are Higgs fields. And that's just a snapshot. So there's just a bazillion of these. We could create them, millions and trillions of them. And then sometimes the fields go sideways. They try to come out sort of like flat. But sometimes they encroach on each other and go sideways. And there's another one that's just spooky. It's the only one I've ever seen of it. If they want to do some real research, this is what they should be doing. Well, I know they're trying to do this, but they want to use their big colliders. They don't want to go into small, because this is almost costs nothing. All right, so don't forget, that's what a proton is made out of. We work with much smaller than this. We work with two of these, two blacks and two of the whites. And this, we have separated those, as I showed you. The black and the white can separate and go. The white goes into a shower. The black just goes on its way. It can't get smaller. It can't get bigger. It's a fixed particle. And the black doesn't mind being on top of itself. It doesn't mind being on top of itself. I'm not sure it attracts itself, but it doesn't mind being on top of itself. But the white desperately wants to be attached to the black. And they sort of sit side by side. Here's what happens. These are the two particles that make up everything. There's nothing that isn't made of these. Not a single thing. Your eyeballs, your earlobes, everything are made of these two particles. This is atomic vapor. I call it atomic vapor. Now, what happens to the atomic vapor? It starts to condense. All right, it wants to condense. Its mission in life is to be holding tight to that, which is called a gluon. They glue on together. Now, at this point, we would call that an electron. We never knew that the black particle existed. We always thought it was just a little negative little thing that had a lot of energy and no mass. Well, it has mass because the black part has the mass. And I believe 1,839 of these makes up one proton, which is one atomic mass unit. But it takes, say, 1840 particles to make that one atomic mass unit. Now, this is an electron. These create heat. They're not electricity. And they're not even static. Static is just that part. And electricity is just that part. It has no weight, but it has a hell of a kick. Now, two of these glued back to back, just like two-bar magnets, create a photon. And why are they glued like that? Well, first of all, these two want to be together. 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 And they lock in to become a photon, which creates a big field surrounding, a big field. A very big field. This does not have a field. The black, I can't find any field, I don't think. This is the one that does the pushing and shoving, the white one. The black pushes the white one, but I don't think the black really has a field. The white one has the field, but it really wants to be glued to the black one. Does the black one just have an attraction field? That's possible, but it certainly doesn't push the other blacks away from it. They'll sit right on top of either. They don't care. The white, no. The white create what they always call was an interference pattern, which says one, get away from me, you get away from me, you get away. They always thought it was because of this flappy. No, when they come through the Venturi, they're spinning, and it says, go you get away from me, you get away from me, and it creates these lines. So these are photons, these are gluons. This is time to get into physics. This is time to get into chemistry. It's time to get into everything. Everything into sciences now has to change because this changed. The standard model doesn't work. This works for gravity. The more black particles you put together, the more gravity you have. If you don't have black particles, you don't even have any mass. This is where the mass is. It's in stuff. Everything about all of us. are coated with, or inside of us is all this dark matter. Most of it has other little particles attached to it, making up protons and neutrons, yes. But the dark matter is the only thing that really has any substance to it. If you pushed all of these white ones, or I don't care what color they are, these are the dipole electrons right there. These are the white electrons. You force those into a battery. You didn't put any weight whatsoever in that battery, and that battery can make your car run all day long. These have no weight, and they have all kinds of energy, and it's from pushing fields. And the black one wants that field so desperately, or the white one wants to go to that field so desperately, that it push everything out of its way. It'll burn right through you to get to ground. Ground is almost all dark matter, basically. It's because you're standing on, bouncing on dark matter right now. Otherwise, you just go right through that. You wouldn't even hit anything. You have to have these attached to that to get solid matter. And when you get a certain quantity of them, you become an atom. And then a certain number of atoms attached together become molecules. Molecules do things in life, and they create products and so forth. But everything comes from the atomic vapor, which is these two particles. That's atomic vapor. And it condenses, and then it condenses more, and then it condenses more. The first condensation is a gluon, which is a gluon. And the second stable condensation is a photon. And then after that, they don't condense and stabilize until they hit about 1840, which is a hydrogen atom core. Right in that area, 1840, I would say, of these particles together. And the black goes to the center and the white goes all around it. Now, the key of hydrogen is just so explosive, it's unbelievably explosive. And you say, well, why would that be explosive? It's just one tiny little particle. Because there's nowhere else for it to go. You hit a spark into that and it just explodes because it can't get any smaller. The spark sets all of those particles that are surrounding the core into chaos. And it is chaotic. All right, they misinterpreted this. I'm telling you right now. They're saying that they see quantum activity, so energy, basically, and it vanished. It was like the brain was using quantum magic to work its wonders, and then when they fell asleep, there was that energetic level went right down to basically nothing. All right, this is where they're making the big mistake here. They're thinking that all this quantum activity is something about the way our brain processes things using these entangled particles. And that's not true at all. When they see these lighting up spots in the brain, that just means the molecular activity in there is facilitating some kind of synapse, basically, is the way I see it. You're getting electrical signals. Those are electrical signals. They're little quantum electrical signals. They're little sparks, basically, is what they are. When you go to sleep, they go to sleep. If you can get into that deep sleep, they just shut down, apparently, because that's what they found. And they said, oh, that just tells you how, I don't know what they think it tells you, but it's going to completely rewrite what we know about how our brains process information. And they think it's because that can send a piece way off to there, and then it will come back to you later when you wake up or something. I don't know what they're thinking, but that's not the way it works. They do not entangle and stay together forever. So this is what they're seeing, is little bursts of energy. And they say that's why they're entangled and they're just holding on to each other. It seemed to suggest quantum entanglement was actually happening. All right, they're talking about it lined up only when they were conscious. Well, that makes sense, because when you're conscious, you're thinking. Some people are. Not a whole lot, but some are. And it just happened when they were conscious and aware. When they fell asleep, the signals vanished. So all they were doing is just relaxing. No more, focusing on things, thinking about things. I have a hard time sleeping because I'm continuously thinking about things. I can't help it. It's just something going on in my mind. I probably got some kind of symptom of something. But people that think, I can't imagine just, I don't know. It doesn't make sense to me that they don't understand this. The more processing your mind is doing, the more energy you're going to expend. It's just the nature of the beast. And specifically, nerves have what they call a synapse, which is an electrical signal. See, this is where they're totally wrong. It says what happens to one particle instantly affects the other one, even if it's on the other side of the universe. Even between the distance, that's quantum phenomena. It's happening inside your brain for some time. They think something is holding on to something else. Now, the myelin sheaths is a problem with when people have autism and all kinds of other things. The sheaths control the signals and through these synapses. All right, here's what this is right here. Chemical reactions release electrical energy in the form of an electric current. Well, that's the synapse. Now, when you're thinking, you got to make that synapse fast. That means basically voltage, which means how much intensity it puts out. So they're going to see those as little tiny sparks, yes. And when you're sleeping, you're not sending out those sparks. But this is the kind of electrical energy you're going to have chemical reactions in your brain. And everything in your brain creates this to create an electric current through those little tiny wires and into your neurons. So that however they deal with it there, I don't know. But that's how you get the signal from one place to the next. When it gets to there, something's going to happen. Now, the only way any of this can happen, this chemistry, fast enough for these chemical reactions to work on the flow of energy through your neurons, is to have enzymes, because enzymes create the chemistry to do this at up to billions of times a second. Now, don't forget, the only place you can get enzymes from are from bacteria. They make them called ribosomes. Without enzymes, the body's vital biochemical reactions would slow to a near standstill, leading to death within minutes. The speed of these enzymes is just incredible. It's essential processes like nerve conductions, heart contraction, energy production, little sparky things would be severely impaired because you don't have the enzymes. You're dead. You see this? I've been preaching about probiotics in your body. These are the things that make the enzymes. Now listen to what it says. Without enzymes, biological reaction essential to life takes 2.3 billion years. This is the UNC study. And this goes back to 2008. So he was a distinguished professor of biochemistry and biophysics, member of the National Academy of Sciences, co-author. Charles Lewis, PhD, published a report in November issue of Proceedings of National Academy of Sciences showing without enzymes speeding the process, it would take 2.3 billion years to complete these vital biological transformations. All right, without having these enzymes. So what about them? Where do you get the enzymes from? Well, the only place you get them from is bacteria. And listen to this. All biological reactions within human cells depend on enzymes. All biological reactions. Everything you do inside, which means digesting your food, creating the products to build your bones, your muscles, your tendons, creating all the products for your life. Now listen to how fast this happens. All biological reactions within the human cells depend on enzymes, their power as catalysts. enables biological reactions to occur usually in milliseconds, which is thousandths of a second. However, how slowly would these reactions proceed if they did it all by themselves without any enzymes, in the absence of enzymes? Minutes, hours, days. And why even pose the question? Because if you don't have the right bacteria in you to create the enzymes, you're going to be sick, and you can get sick almost instantly. One scientist who studied these issues, Richard Wolfenden, alumni distinguished professor of chemistry at the University of North Carolina, Chapel Hill, holds posts in both the medicine and sciences and is a member of the National Academy of Sciences. He wrote, without a particle enzyme or biological transformation he deemed absolutely essential in creating the building blocks of RNA would take 78 million years. And we do it in a millisecond. Do you hear what I just said? To make DNA and RNA would take 78 million years without that catalyst. Now we found a reaction that, again, in the absence of a catalyst, you don't have the catalyst, is almost 30 times slower than that. Its half-life, the time it takes for half the substance to be consumed, is 2.3 billion years, about half the age of Earth. Enzymes can make that reaction happen in milliseconds. That's the key. That's the key. You don't have to, and let's just talk about where do the enzymes come from. Now, don't forget, these are some top-end guys. This is University of North Carolina, and they're well skilled in several areas: biochemistry, biophysics, National Academy of Sciences. These guys, that's the kind of guys I like to see doing the research. And he came up with this, and he's saying if you don't have the enzymes, you're going to die, or you're going to be extremely sick, because there's thousands and thousands and thousands of different enzymes in your body, and every one is created from a bacteria. And how would I say that? Well, because I did my research, and yes, bacteria considered factories of enzymes. They are primary and efficient source of producing various enzymes. Yes, in your body, that's what they do. They can make them artificially now. All right, but our body makes them automatically because the bacteria that lives inside of us. And you have to have thousands and thousands and thousands of different strains of bacteria, because there are that many different chemicals. And you saw that if you don't have one, you call on it to do the job, it's not there. But if you call on it and it's there, virtually instantaneously, it does its unbelievable amount of breaking down and reconstructing. That's what an enzyme does. They're basically the same enzymes and proteins. Enzymes break things, proteins build things back up. Enzymes make the bits and pieces, proteins build the bits and pieces back up. All right, you see that? There are thought to be approximately 75,000 different enzymes in the human body, which are proteins that act as catalysts. We know about that. Well, where do the enzymes come from? Well, they come from the bacteria. So there's got to be probably 75,000 different types of strains or species, or whatever you want to call them, of bacteria or fungus or mold or yeast or whatever they are living in our bodies, doing these specific jobs of creating enzymes. Now, don't forget, here's how I can prove that these enzymes are so important, and the bacteria that create them are so important, is from acute radiation sickness. And you're going to say, Roger, well, how the hell you come up with that? Because an acute radiation sickness is a pulse of ionizing radiation. Well, what does ionizing mean? It literally destroys little tiny living creatures that are called bacteria. All right, this basically proves what I'm saying. The radiation of ionizing, short period ionizing radiation, causes acute radiation syndrome. All right, it's also known as radiation sickness. Now, here's the deal. or radiation poisoning is a collection of health effects, a collection of different things that happens. They're caused by being exposed to high amounts of ionizing radiation. Ionizing means it tears little cell walls apart of little tiny creatures, which are the bacteria that create the enzymes. So you're being exposed to this, all of a sudden you get a pulse. And it goes right through your body. And it's ionizing, which means it's strong enough to destroy these cell walls. So in a short period of time, the symptoms can start within an hour of exposure, almost immediately, and they can last for months. Early symptoms are usually nausea, vomiting, loss of appetite. You've lost all your enzymes, all your bacteria. Within an hour, you are experiencing all of these symptoms. Now your body's trying to recreate these bacteria. Some of them are still alive. Hopefully. Depends on how much you got sick. The more intense it was, the more you're going to die. The less symptoms. Now, it says they can start within an hour and can last for several months. Now, I would like to see him do the bacterial analysis before and after. I'm going to guarantee you wiped out all your good bacteria. Early symptoms, usually nausea, vomiting, loss of appetite. In the following hours or weeks, initial symptoms may appear to improve before the development of additional symptoms, after which either recovery or death follows, one or the other. If you can get enough bacteria coming back, you're okay. If not, you're done. It involves a total dose of greater than so many rads that generally occurs from a source outside the body, delivered within a few minutes. This happens at nuclear reactors and so forth. And I got a story to tell you about some woman that contacted me. She was telling me that whatever. And she was going to go to be at CERN, to work at CERN. And I said, they're going to give you a badge to wear. And the more times you get hit with these, the more that badge says sooner or later you killed all your bacteria. What it does is it wears down your bacteria because you're being irradiated. Small amounts, but enough to damage those bacteria. They are tiny little, delicate little creatures. And the other thing that happens is we eat a lot of things that have weed killers on them. And weed killers are also bactericides. They kill bacteria. And we eat those because they spray them on the plants. So that also kills the bacteria in our body, which are the producers of the enzymes, which are missing. You're dead almost instantly. Literally, it said within 2 minutes you're dead. All right, you see this? They pretty much divide this acute radiation syndrome into three different things. Bone marrow, which happens at 0.7, so you don't have to get a whole lot of radiation to affect your bone marrow, up to 10. Neurovascular occurs at doses over 50 GYs. The cells that are most affected are generally those that are rapidly dividing. That's basically bacteria. Bacteria, that's how bacteria works in your body. It's continuously dividing, and that's what gets killed. And that's why you get sick to your stomach, you get nausea, you get vomiting, you get diarrhea, you get bloating, you can't eat, you can't digest your food, you get weak. And absolutely no question, if they did fecal swabs of what is in your body, I can guarantee you there's going to be a whole lot of stuff missing. Okay, so let's finish up where we started. I said all of this stuff is tied together, and even all this stuff up here is tied together with the evolution of the Earth. Okay, so those are my statements that I am going to enlighten you. Hopefully I have. And there is much more enlightening to do. Much of what we had thought was settled science has become very unsettling. Now, I am going to continue, as I do daily, to present the evidence to support the claims that I am making. And they are extraordinary, and as Carl Sagan, who was not one of my favorites, said, extraordinary claims require extraordinary evidence, and I never present a claim without evidence. I invite some kind of discussion. I could be very polite. I have no problem with that, but I need some discussion. That's all. So anyway, that's what I have shown once again today. And maybe Joe Rogan will let me speak on his show about the things that, because I've seen a lot of the things he presents, and I like to speak about them, because most of the stuff is from mainstream-ish. They try to skirt around the edges, but until you understand mud fossils, number one, that's first of all, because that's geology is biology turned hard. And secondly, you have to understand dipole electron flood theory. You don't understand those two things, you're off the mark. You can't even get started. You don't even know what the Earth is made of. You don't know what even light is made of, gravity, heat, all these energies, dark matter. We're made of dark matter. All of this stuff is covered under the dipole electron flood theory, 100%. And that is the dark matter right there. That black particle. They've seen it, they just don't know what it was. We see it attached to light, and it has to be there to push the light. It's the particle that drives the light, and that I can show too. So all of these things I have shown, there's the black particle right there pushing the white. In this particular Venturi setup, some comes through with it, and the black literally pushes the white ahead of it, because the white just got gobbledygooked up here. And it takes advantage of that to push it in a wave form, which is not normal. You don't normally see that. Rod Warren did these experiments, and absolutely stunning work. This is before it accelerates, just as it's beginning to accelerate and push all those particles out of the way. All right, and this was all done with CMOS, complementary metal oxide semiconductor silicates, which CERN is also using now, but they had to harden theirs because they're using too big particles. The particles they're using, these X particles, destroyed the CMOS before. But we were using light, so we didn't have to worry about that. They still want to use these big, gigantic things. For what reason? I have no idea. And so they had to harden the CMOS, which they did, and they upgraded CERN. I think it took 3 years. Anyway, they have come up to our standards. This is what it is. That's the particles. Look at the black with the little glowy edge around it, which has all the mass. It's like a bowling ball. And it is dark matter. And these are the two glowy parts. They can get bigger and smaller. And that's what squirts through. So maybe Joe Rogan will let me speak about this. All right, because it is the Dirac neutrinos, only they don't understand. This is the no matter here. This is all energy, and that's got the matter. Anyway, I love you all. We're going to talk. Next thing I'm going to do is go into magnetism and the fields that are affected by magnetism. It's very interesting. Magnetism is a little bit puzzling, to be perfectly honest with you, but we'll dig into it together and do some experiments. All right? I love you all. Bye.